Hi, it's Jack from CodeWiz. Today, I'm going to show you the core components of a computer and how they work together to run programs and code. The core components of any computer, whether it be a laptop or a desktop, are the CPU, the GPU, the RAM, the motherboard, the power supply, and the storage drives. Firstly, let's go over the CPU, or Central Processing Unit. The CPU is like the brain of a computer. CPUs and desktops or laptops are usually made by Intel or AMD. The job of the CPU is to process instructions by making calculations. This allows it to run programs. The calculations that the CPU processes are comprised of binary zeros and ones. Overall, the CPU is one of the most important computer components as it is impossible for a computer to run without one. Different CPUs have varying amounts of power. The amount of clock cycles that a CPU can reach is measured in gigahertz. Some calculations only take one clock cycle, while more complex instructions may take many clock cycles to complete. A 1 gigahertz CPU can reach 1 billion clock cycles per second. Today, 5 gigahertz CPUs that can do billions of clock cycles per second are readily available. Another very important specification that contributes to the speed of a CPU is its core count. Cores on a CPU are what allow processors to do multiple tasks at once. A dual-core CPU essentially has two separate processors that can work on independent things at the same time. Today, 16-core CPUs can be bought for under $1,000, and high-end 64-core CPUs are available. The RAM, or Random Access Memory, works very closely with the CPU. RAM takes the form of thin sticks in a computer. It acts as the short-term memory that stores data the CPU needs for what it's currently working on. It's incredibly fast and is crucial to the operation of a computer, just like the CPU. RAM is categorized by two specifications, gigabytes and megahertz. The amount of capacity that the RAM has is measured in gigabytes. The larger the capacity of RAM, the more things the computer can work on at once. Common capacities of RAM today are 8, 16, and 32 gigabytes. Faster RAM allows the CPU to retrieve data more quickly. This is measured in megahertz, and common speeds are 2066 to 3600. RAM is considered volatile memory. This means that when power is removed from the RAM, all data is erased. This is one of the reasons why we don't use RAM to store our files. RAM is also very expensive for the amount of storage you get because it is so much faster than other forms of storage like flash drives. The GPU, or Graphics Processing Unit, is often housed on a component called a graphics card. It's used for tasks like gaming, 3D modeling, and rendering. GPUs have cores, just like a CPU. However, the cores are structured much differently. A GPU can have many thousands of specialized cores, all used to process and display frames to a monitor. Many GPUs have different types of cores that work with different workloads. Cores on a GPU are specialized to do one type of task, unlike CPU cores which can do many different tasks. GPUs also have a clock speed, measured in gigahertz. Today, it's in the range of 1 to 2.5 gigahertz. The two main GPU makers are AMD and NVIDIA. Some computers do not have graphics cards. These systems use an integrated GPU, which is a specialized GPU part of some CPUs. They're much less powerful than standard GPUs, but they use less power. This makes them ideal for laptops. The two common types of storage are SSDs, solid-state disks, and HDDs, hard disk drives. In a basic sense, SSDs are faster, larger, and more advanced flash drives. They have no moving components and are very resistant to physical damage. SSDs are much faster than hard drives, but they're also more expensive. They're comprised of flash chips that store data, and they come in two form factors. These are M.2 and SATA. M.2 drives are very common in laptops because of their small size. They're also becoming more common in desktops because they plug directly into the motherboard with no need for cables. HDDs are comprised of physical spinning platters. A read and write head glides across the platters and magnetically charges parts of the platters. HDDs are very susceptible to physical damage and have been around for decades. They're much slower and cheaper than SSDs. The motherboard is what connects all of the computer components together. It's a circuit board with a socket for the CPU, DIMM slots for the RAM, PCIe slots for graphics cards, spaces for storage, and ports like USB and Ethernet. In a laptop motherboard, these sockets and slots are still present, but they're often soldered together and not user replaceable. Laptop motherboards are custom sized and built for the laptop that they're in. Desktop motherboards have standards for sizes like ATX, Micro ATX, and Mini ITX. The motherboard also contains another very important component, the chipset. The chipset acts as a middleman between the CPU and everything that's plugged into the computer. It connects components like USB ports and graphics cards to the CPU so they can work together. Modern CPUs handle the connection to the RAM by themselves, however. The PSU, or power supply unit, is the component that takes AC, alternating current, power from the wall, converts it to DC, direct current, and distributes it to all the parts of the computer. Laptops and desktops have very different ways of doing this, however. In laptops, the power supply is located in the charging cable as a brick. In desktops, power supplies are stored inside of the computer and they look like small boxes. Those are the main components of a computer. There are some other very important parts, however. The CPU cooler is what transfers heat away from the very hot CPU. Wi-Fi and Bluetooth antennas provide wireless connections. Every computer also must have peripherals like mice, keyboards, monitors, and speakers. I hope you learned something in this video. Make sure to like, subscribe, and I'll see you next time on CodeWhiz.